Assalamu alaikum and welcome to Cambridge Chemistry channel with Sarwat Ahmed. In this video I will be solving the questions which were found to be most challenging from 2019 paper 1 to 9701. Let's start. Question number 2. Oxygen has three stable isotopes O16, O17, O18. All three isotopes are present in a sample of oxygen gas O2 which was analyzed using a mass spectrometer. How many peaks associated with the O2 positive ions would be expected? So let's solve. The possible MR is O16 plus O16 is equal to O32 positive. Second is O16, this possibility O17 is equal to O33 positive molecular ion. Third is O16 isotope, O17, 18 isotope is equal to, the possibility is 34 O2 molecular ion. 4 is O17 plus O17 gives 34 molecular ion. The fifth one is O17 plus O18 will give O2 positive with 35. 6 is O18 plus O18 will give O36. As we know that mass spectrometry, in mass spectrometer different molecular mass gives different peaks, so there are different MRs. So let's find out that how many peaks are there. This O32 molecular ion gives one peak, this is another peak. Number 2, 34 molecular ion and 34, so this will give peak but this will not give peak because both have same. So and O35 also gives one different peak. O36 also will give different peak. So total peaks are 1, 2, 3, 4 and 5. The option is B. Next question is question number 6. X, Y and Z are all gases that behave ideally and react according to the equation shown. When 3 moles of X and 3 moles of Y are placed inside a container with a volume of 1 dm cube, they react to form the maximum amount of Z. The final temperature of the reaction vessel is 120 degrees centigrade. What is the final pressure inside the reaction vessel? We know that reaction is X plus 2Y to form 2Z. We know 1 mole react with 2 moles to form 2 moles of Z, and in question when 3 moles of X and 3 moles of Y are placed inside a container with the volume of 1 dm cube, they react to form the maximum amount of Z. So we know that if 1 moles react with 2 moles gives 2, and in question 3 moles gives 3 moles. React, it means 3 2/3 will be given 1.5 5 moles are consumed while 1.5 moles are left behind left, and Y is the limiting reactant. See, if 1.5 moles of X is left and 3 mole is the limiting reactant, if 1.5 moles of X react with 3 moles of Y to form 3 moles of Z, because limiting reactant determines the mass or mole of the products. So if Y is 3 moles, then Z will definitely be 3 moles. So this is X mole, this is Y mole, and this is X Z mole. So we have total moles in this reaction are 1.5 plus 3, because these moles are consumed and left behind is 1.5 and 3 moles are produced. This Y moles are consumed, are used, because this is limiting reactant, and 3 moles are formed and 1.5 moles from X is leftover moles and produced. The total moles are, this is Z mole and this is X mole, that is equal to 4.5 moles. So now we have 4.5 moles by using PV is equal to nRT. P is equal to nRT over V. We know that P is equal to moles are 4.5. R is the general gas constant, that is 8.314, value from data booklet, and 3, this is 120 degrees centigrade, and volume temperature will be taken in Kelvin, which is equal to 393 divided by volume in Pascal, and over here 1 dm cube, which is equal to 1 into 10 raised per 2 minus 3. So 1 into 10 raised per 2 minus 3. The answer will be, pressure will be in 1.47 into 10 raised per 2, 7 Pascal. The correct answer is C. The next question is question number 10. Ethyl ethanoate undergoes the following reaction: CH3CO2 C2H5 plus H2O to form ethanol and ethanoic acid. Kc is equal to 0.27. Equal amounts of ethanoic acid and ethanol were mixed together and allowed to reach equilibrium. At equilibrium, the concentration of both ethanoic acid and ethanol were 0.42 mole per dm cube. What is the concentration of ethyl ethanoate at equilibrium? So let's the reaction is reversed. So when we reverse this reaction, the Kc is equal to 1 over 0.27. We write down this reaction like this: C2H5OH plus CH3CO2H to form CH3 ethyl ethanoate, CO2 C2H5 plus water. At equilibrium, the concentration of both ethanoic acid and ethanol were 0.42 mole per dm. Let's assume this is 1 1 react with 1 and 1, and if concentration of both ethanoic acid and ethanol were 0.42 at equilibrium, the concentration of ethanol is 0.42, so it is 0.42 and it is assuming x and x. Now Kc is equal to x divided by 0.42 and 0.42. Now Kc is 1 over 0.27 is equal to x square divided by 0.42 into 0.42 is equal to 0.1764. So this is 1 over 0.27 into 0.1764 is equal to x. So by taking square on both sides, so this value will become 0.6533 is equal to x square. By taking under root x is equal to 0.6533 under root, and x is equal to, x will become equal to 0.81 mole dm inverse cube. So the correct option is C. Next question is 15. How many of the solution shown when added to separate portions of magnesium sulfate solution produce a white precipitate? Let's check. Magnesium plus HCl to form magnesium chloride, this is aqueous, plus water. So next, magnesium, so this is HCl does not form precipitates with magnesium. Magnesium sulfate magnesium sulfate plus HCl to form magnesium chloride plus Mg plus H2SO4. So HCl will not form precipitates. This is aqueous solution, this is again aqueous. So let's check other. Magnesium sulfate plus ammonia to form magnesium hydroxide plus ammonium sulfate. This is aqueous and this is solid precipitate. So ammonia form precipitate with magnesium sulfate. Let's check other. Ammonium CO3 plus MgSO4 MgCO3 plus ammonium sulfate. This is aqueous, this is solid. So ammonium carbonate also form white precipitate. So barium nitrate react with magnesium sulfate to form barium sulfate white precipitate solid plus magnesium nitrate. This is aqueous. So barium nitrate also form white precipitate. So option is D. Next question is 31. When O2 reacts with H2S, the products are SO2 and H2O. Mixture Y contains an equal number of the two molecules shown and no other molecules. Oxygen 16 isotope and oxygen 18 isotope. Hydrogen when react with hydrogen 1 32 isotope, hydrogen 1 isotope. Which statement about Y are correct? The average MR in Y is 34. So this is 16 into 18, that is equal to 34, and H1 plus 32 plus 1 is also equal to 34. The average MR in Y is 34, so this is correct. If some oxygen molecules are removed from Y, the average MR of the mixture remains the same. Yes, this is also correct. If oxygen molecules are removed from Y, the average MR of the mixture remains the same. This is also correct. When mixture Y is ignited, some H2S remains unreacted. So let's write down the chemical equation. H2S plus O2 to form H2O plus sulfur dioxide. So there are 3 moles of oxygen, 3 atoms of oxygen on product side. Let's balance by 3 over 2. So this is 1 mole, ratio 3 over 2, that is 1.5 moles. So H2S is excess reactant, so left unreacted, some amount of H2S left unreacted. So when mixture Y is ignited, some H2S remains unreacted. So this is also correct. 1, 2, 3 are correct. The option is A. Next question is 40. An oxidizing agent that can oxidize ethanol to ethanoic acid or ethanoate ion will also oxidize methanoic acid to carbon dioxide and water. Will also oxidize methanoic acid to carbon dioxide and water. Which reagent on heating will react differently with HCO2 and CH3CO2 H? Let's consider this is aldehyde. First reagent will react differently. Sodium carbonate, so this is carboxylic acid, and this is also carboxylic acid. Carboxylic acid. Both react with sodium carbonate plus acid to form salt, water, and carbon dioxide. So this is incorrect. Failing reagent as HCO2H is aldehyde. So can oxidize aldehyde, hence can oxidize to form HCOOH. But carboxylic acid can't oxidize carboxylic acid. Dilute acidified KMnO4 oxidize aldehyde but cannot oxidize carboxylic acid. So 3 is also correct. So if 2 and 3 are correct, the option is C. If you like this video, please subscribe and share this.